So welcome to Lesson 5, Discriminants. So we're going to do a quick review of what we did last class and then really continue our discussion about X-intercepts and the number of X-intercepts a quadratic function can have. So yesterday we learned a very important relationship. We learned that the solutions or roots of a related quadratic equation are the same as the X-intercepts or zeros of the corresponding quadratic function. So we looked at this particular relationship and we graphed some parabolas. We noticed that their X-intercepts were the same as the solutions we would obtain if we converted a function to its related quadratic equation. So let's work backwards this time. It says solve the following quadratic equation. Explain what your solutions mean with respect to the corresponding function. So here we have a quadratic equation to solve. Again, how do we know it's an equation? It's not a function because it doesn't have an f of x, and we said that we're only going to work with single variable equations. This has a single variable. We know it's quadratic because, again, the fact that the highest exponent on an x is 2. So if it says to solve the following quadratic equation, again, we have two options, factoring or the quadratic formula. Let's go with, but let's always start with factoring. So if we try to factor this, again, we see a trinomial. So we should be left with x5, x2, plus and minus. Again, I'm not going to show you the steps for factoring because it should be second nature at this point. So we factored our quadratic equation. Now we're going to solve it. So let's set each factor, or each bracket in this case, to 0. So we've solved the quadratic equation. Next, we need to describe what these solutions mean with respect to the corresponding quadratic function. So this was our related quadratic equation here. This is associated, so I'm going to write associated with the function f of x is equal to x squared plus 3x minus 10. So if this is the function and this is the related quadratic equation, the solutions or the roots of the related quadratic equation are the same as the x-intercepts or the zeros of the corresponding quadratic function. So what I can conclude here is f of x, our particular function, has -5, 0 and 2, 0 as its x-intercepts. So again, the solutions to the related quadratic equation is the same as the x-intercepts or zeros of the corresponding function. So if they give you a function, you can convert it to a related quadratic equation, solve it, and then talk about the x-intercepts, or they might just give you the related quadratic equation. You would have to think about what function it's associated with and make the exact same conclusions. So this was all from yesterday. Let's move on to today's lesson, which is focusing on the number of x-intercepts that a quadratic function can have. I know the grid doesn't look so nice on this camera, but again, you should be able to read it on your own page. So, minds on activity. A quadratic function can have 0, 1, or 2 x-intercepts or zeros. What I want you to do is draw 3 quadratic functions with 0, 1, and 2 x-intercepts respectively. Choose an appropriate vertex and use the 1, 3, 5 step pattern. So what I want you to keep in mind is that there's going to be a whole bunch of answers that all of you can produce here. So pause the video now, draw a parabola with 0 x-intercepts, 1 x-intercept, and 2 x-intercepts, and then we'll take up our answers. So pause the video now. So as I mentioned earlier, there are several solutions that we can have for these. I'm going to go with one solution for each. So I want to draw a quadratic function with 0 x-intercepts. So I'm going to choose a random vertex, in this case, And remember, quadratic functions can open up or down. If I open down, it will cross the x-axis here and here, and I will have x-intercepts. So if I open it up instead, there will be no x-intercepts. So following the step pattern, I move over one, move over one, up one, then move over one and up, go up 3. So in this case, again, I'm going to take out a pencil because I know I cannot draw parabolas with my pen. So here, if I drew this particular function, I see a function, a quadratic function that has 0 x-intercepts. I'm going to draw one more example to show you there could be many examples. I'm going to maybe choose a vertex here this time. Again, if I make it open up, it will cross the x-axis. There will be x-intercepts. So I'm going to make it open down. So the step pattern, move over one, down one, and then move over one, down 3, and then do the symmetrical images. So if I connect this, I have another quadratic function that has 0 x-intercepts. Let's draw one, a quadratic function with 1 x-intercept then. Again, I'm going to show you 2 examples of this. So if I have 1 x-intercept, what that essentially means is that the vertex lies on the x-axis. So following the step pattern, I essentially have this. So I can connect it. Or I can have something that looks like this, where if I had this as my vertex, I can go down instead. Notice I'm always using the 1, 3, 5 step pattern. You could have used 1A, 2A, 1A, 3A, 5A, where A is any value. So if you chose to go with A is 2, so you went with 2, 6, 10, that's also acceptable here. Okay, so now again, I have a parabola. That only has 1 x-intercept. Now let's draw 2 examples of parabolas with 2 x-intercepts. So I'm going to choose something up here. Again, I know if I go down, it will cross the x-axis. So I'm going to go down. And I'm going to do the same thing over here, where I'm going to start here, go up, and then go up again. So if I connect these parabolas, I get something that looks like this. And something that looks like this. Sorry, that looks weird. I'm going to fix it. Okay, so these are examples of parabolas with no x-intercepts. These are examples with 1 x-intercept each, and these are examples with 2 x-intercepts each. So if I take a look at these parabolas, these are, again, functions. The related quadratic equations of each of these functions would have 0 solutions. Remember, if the related quadratic equation has 0 solution, then the corresponding function will also have 0 x-intercepts. Here, these are the functions. The related quadratic equation of each function would have 1 solution. So if the related quadratic equation had 1 solution, the function will also only have 1 x-intercept. Similarly here, each of these functions have 2 x-intercepts, so the related quadratic equation should have 2 solutions. So this is what I mean by a quadratic function can have 0, 1, or 2 x-intercepts. From a graph, so this is what's getting us, so we're going to learn a technique to find out how many x-intercepts a quadratic function can have easily. So from a graph, it is easy to determine the number of x-intercepts of a quadratic function. Why? Because we can read it right off. Here, we know it doesn't cross the x-axis. There are 0 x-intercepts. Here, each parabola crosses the x-axis once. There's one x-intercept. Here, each parabola crosses the x-axis twice. There are 2 x-intercepts. So from a graph, it's easy to determine the number of x-intercepts of a quadratic function. And as a result, the number of solutions of the corresponding related quadratic equation, because we know those numbers match up. We can also obtain this information using something called the discriminant. So the discriminant can tell us how many x-intercepts a quadratic function has, and therefore how many solutions its corresponding related quadratic equation has as well. So the discriminant is the expression located under the root sign in the quadratic formula. It can help one determine the number of solutions to a quadratic equation. So here we have our quadratic formula. Let's label that. So this whole thing is called the quadratic formula. To get the discriminant, all we do is we look at the expression located underneath the square root sign. So in this case, it's b squared minus 4ac. This is our discriminant. So I introduced what the discriminant was on the previous page. So let's explore, how does the discriminant tell us the number of solutions? So instead of me just giving you the relationship, we're going to explore just like we did last class. So in order to discover the relationship between the discriminant and the number of solutions for a quadratic equation, you're going to, 1, state the number of x-intercepts that the quadratic function has. 2, predict the number of solutions that the related quadratic equation will have. 3, calculate the discriminant. And 4, state the relationship between the discriminant and the number of solutions for a quadratic equation. So just like last time, there are different scenarios, and we're going to just work through it and hopefully see patterns through this activity. So the first scenario, I've already categorized the scenario for you. Discriminant is positive, but let's see what that actually means. Okay, so let's start by writing out the quadratic function. The function is written here for you, so all we're doing is we're copying it down. F of x is equal to x squared minus 4. Using the graph, how many x-intercepts does this quadratic function have? Well, it has 1 here and 1 here. Again, we don't care about the specific x-intercepts. We just want to know the number of x-intercepts. So there are 2. Based on this, you should be able to answer this question. If a quadratic function has 2 x-intercepts, how many solutions would its related quadratic equation have? Well, let's write out the related quadratic equation first. If this is the quadratic function, the related quadratic equation is 0 is equal to x squared minus 4. And if the function had 2 x-intercepts, then the related equation will have 2 solutions. Okay, so far, so good. The next thing we want to do is we want to calculate the discriminant. So we have b squared minus 4ac. So I said that this was the discriminant. What we need to do is we need to find the a, the b, and the c value and plug it into our discriminant. So let's take a look at our equation here, our function equation. We have a. A is ultimately equal to 1, so that's what's attached to the x squared here. B is the value attached to the x. There is no x here, so it's 0. And then c is the lone value, or the constant, so -4. So now that we have our a, b, and c values, we can plug it in. So b squared is just 0 squared minus 4. A is a 1, c is a -4. So 0 squared is just 0. And -4 times 1 times -4 is positive 16, giving us 16. So there isn't really a pattern that you can see, but we can form this conclusion. If we saw multiple examples, you might see the pattern. So if the discriminant equals a positive number, which is what it equals here, so b squared minus 4ac gave us positive 16, a positive number, then the related quadratic equation has two solutions. So we saw that this function had two x-intercepts. Its related quadratic equation had related quadratic equation had two solutions. Wow, my brain is not working. Two solutions. Then what we did was we found the a, the b, and the c value. Something to keep in mind is that the a, the b, and the c value will be the same for the quadratic function and to the related quadratic equation. So we got the a, the b, and the c value, we plugged it in, and it gave us a positive discriminant. So what this tells us is that whenever your discriminant is a positive number, you will have two solutions for the quadratic equation, and therefore two x-intercepts in the corresponding quadratic function. Let's look at scenario 2, again, working through the exact same material. So the quadratic function here is fx is equal to x squared minus 6x plus 9. Let's take a look at the graph. How many x-intercepts does it have? Well, it only crosses the x-axis here, so it has one x-intercept. Then we look at the related quadratic equation, so we just convert the f of x to 0, so 0 is equal to x squared minus 6x plus 9. And how many solutions would this related quadratic equation have? Again, you know the relationship where the number of solutions for the related quadratic equation equals the number of x-intercepts. So we can safely say that it's 1 again. Next, we're going to go to the discriminant. So b squared minus 4ac. And let's take a look at our equation. So if we take a look at our equation, the a value is what's attached to the x squared, 1. The b value is what's attached to the x, negative 6. And the c value is the low number, so 9. Once we have these numbers, we can plug them in. So b squared is just negative 6 squared minus 4, 1, and 9. Notice that whenever I substitute in something, I keep it in brackets. So let's take a look at this. Negative 6 squared is the same thing as negative 6 times negative 6, which is positive 36. And negative 4 times 1 times 9 is negative 36. 36 minus 36 is equal to 0. So this is the scenario where the discriminant equals 0. What we see is when the discriminant equals 0, then the related quadratic equation only has one solution. So we've seen two things so far. We saw that if we calculate the discriminant and it's a positive number, then the quadratic equation has two solutions. If we calculate the discriminant and it equals 0, then the related quadratic equation only has one solution. So let's take a look at our third scenario here, where the discriminant is negative. So what is the quadratic function? Well, we're just copying this down. F of x is equal to x squared minus 4x plus 5. How many x-intercepts does this function have? Well, here's the x-axis. It's crossing the x-axis 0 times. So 0 x-intercepts. The related quadratic equation, again, replace the f of x with 0. So 0 is equal to x squared minus 4x plus 5. So based on this, remember the number of solutions of the related quadratic equation should equal the number of x-intercepts in the quadratic function. So there should be 0 solutions as well. Let's calculate the discriminant now. So we have b squared minus 4ac. Again, let's take a look at the equation to determine the a, the b, and the c. So here, the equation, the a is just 1, the b is negative 4, and the c is positive 5. So I take these values and plug them in. So negative 4 squared minus 4 times 1 times 5. Negative 4 squared is negative 4 times negative 4, which is positive 16. And then we have negative 4 times 1 times 5, which is negative 20, which gives us negative 4. So in this case, our discriminant is a negative number. So if the discriminant equals a negative number, then the related quadratic equation will have 0 solutions. So I know it wasn't much of an exploration. We did look at examples to kind of see what sort of discriminant values can we expect, a positive, a 0, or a negative, and what that tells us about the number of solutions in the related quadratic equation. So let's form a quick summary here. So here, it's written weirdly, but let's interpret what this means. It says, if b squared minus 4ac is greater than 0. If any value is greater than 0, it's positive. So essentially what we're saying through this notation is if you have a positive discriminant, so again, b squared minus 4ac is our discriminant. We're saying it's greater than 0, so it must be a positive number. So if b squared minus 4ac is greater than 0, we know that there are 2 solutions to the related quadratic equation. Therefore, there are 2 x-intercepts for the corresponding quadratic function, because the number of solutions in the equation equals the number of x-intercepts in the function. You should get really tired of me saying that over and over. If b squared minus 4ac is equal to 0, in other words, if we have a 0 discriminant, there is only 1 solution to the related quadratic equation. Therefore, the corresponding quadratic function will have 1 x-intercept. And if b squared minus 4ac is less than 0, we have a negative discriminant. And if we have a negative discriminant, we saw that there are 0 solutions to the related quadratic equation, and therefore there are 0 x-intercepts for the quadratic function. So all of this, everything we've done so far kind of boils down to this information. This is kind of what you need to remember. If I get a positive discriminant value, what does that mean? If I get a 0 discriminant, what does that mean? And if I get a negative discriminant, what does that mean? So example here, it says determine the number of solutions for the following quadratic equations by calculating the discriminant. Okay, in this question, I fully told you by calculating the discriminant. Even if I didn't give you those words, as soon as you see something like number of solutions or number of roots for a quadratic equation, so instead of saying solve the equation for the roots, it says determine the number, again, number being the key word, you know that you're going to have to use the discriminant. Okay? This kind of works exactly like our equations from before. Before we were able to solve equations, we had to simplify everything on both sides, bring everything to one side. We have to do the same thing here. So this side simplified, this side simplified. Let's bring everything to one side. Again, you want your a to usually be positive, so let's move the 3 over to this side. X squared plus 2x minus 3 is equal to 0. Again, we're not trying to solve it, so we're not going to factor it. All we want to know is the number of solutions. And for that, we need the discriminant, which is b squared minus 4ac. Before I use the discriminant, let's write out what the a, the b, and the c are. So the a here is equal to 1, the b is equal to positive 2, and the c is equal to negative 3. Once I have these values, I can plug them in. So b squared is 2 squared minus 4, a is 1, and c is negative 3. 2 squared is just 4. Negative 4 times 1 times negative 3 is positive 12. And 4 plus 12 is 16. So we found the number, we essentially found the discriminant. We need to find the number of solutions. So the proper way of writing it is, therefore, b squared minus 4ac, or the discriminant, is greater than 0. It's positive. So the equation has two solutions. You can also use the word roots there. I don't expect you to write b squared is greater than 0. If you wrote something like the discriminant is positive, so the equation has two solutions or roots, that's perfectly fine as well. Let's try this example together. And then these two examples, I'm going to pause the video for you to try on your own, and then you can see if you're right. So let's take a look here. Again, remember, before we can find the discriminant, simplify both sides. They're already simplified here. Bring everything to one side. Everything's brought to one side here. And the A is positive, so it's a good bonus for us. Everything's how it should be. So let's start with the discriminant then. B squared minus 4AC. So let's find the A, the B, and the C values first. The A here is the value attached to the x squared, 4. The B, there is no x, so there's no number times x, so the B is 0. And the C is equal to positive 3. Now I can go substitute these values in. So the B is 0 squared minus 4. A is 4, and C is 3. So I have 0 minus 4 times 4 is 16. 16 times 3, 48. So 0 minus 48 is minus 48. So our discriminant gave us a negative value. So you can write, therefore, b squared minus 4ac, the discriminant is less than 0. It's negative. So the equation has 0 solutions, or no solutions. Again, this should be pretty straightforward. I want you to pause the video now, try these two, and then unpause it, play it to see if you are right. Okay, so I've solved the other two here for you. So again, this was simplified. Everything was brought to one side. You write your A, B, and C value. Here, there was no constant, so the C was 0. You plug the numbers into your discriminant. It should have gotten you negative 8. And again, because the discriminant is negative or less than 0, there are no solutions or 0 solutions to the equation. And here, again, both sides were simplified, but it wasn't brought to one side yet. So again, we brought this, the 4x and the minus 1 over because we wanted our A to be positive. So the 4x became negative 4x, the negative 1 became positive 1. We found our A, our B, and our C value, again, plugged it in. It should eventually get you 0. So because b squared minus 4ac is equal to 0, or because the discriminant equals 0, the solution only has one solution. Sorry, the equation only has one solution. So the homework then, the homework is handout C, as well as page 232, number 2AC, 3, 4, A, C, and E. I want to see all of this done. Again, take a picture and send it through the Google Classroom. Thank you.